Okay, so this is a video about percentage yield. And percentage yield is important because if you have a large percentage yield, that means you're going to get more moles of chemical out of your reaction, which is good for the environment. It means things haven't been wasted. It also means you can get more money from it, which is always useful. So how are we going to calculate percentage yield? We're going to follow this little method on the right here, just a 4-step method. And I'm going to apply that to 3 different questions to show you how to use it. So let me set up my question. Let's say we have an apple and a banana, and you can cut them up and blend them together to make a smoothie. And 1 apple and 1 banana makes 1 smoothie. Now, let's say we started with 5 moles of apples and 8 moles of bananas, so a lot of apples and bananas. And by cutting them up and mixing them together, at the end of the day, we ended up with 2 moles of smoothie. So these moles at the bottom here are the moles we started with and the moles of smoothie we ended with. So let's apply that to this method then. So step 1, we're going to find our moles of limiting reagent. Now I've just given you the moles. Often in the question, it will tell you the mass. And so to get the moles, you'll need to do moles equals mass over mR. Or maybe they'll give you the volume and the concentration, and you can use moles equals CV to get the moles. Either way, we're going to find our moles of limiting reagent. Let's put mole LR. Now the limiting reagent is the reagent that you run out of first. So if we look at our apples and bananas, we can see we're going to run out of the apples first because there's less moles of them. And so therefore our limiting reagent is apple. We would say the banana is in excess. So my limiting reagent is 5 moles of apples. Step 2, and this is the bit everyone forgets to do. We need to look at our molar ratio of limiting reagent to useful product. Now in my question, that is a 1-to-1 ratio. For every 1 apple we cut up, we should end up with 1 smoothie. So by looking at my molar ratio of limiting reagent to useful product, we can say the maximum possible moles of smoothie we should be able to end up with is 5. Because it's the same as the apples, right? For every 1 apple, you should get 1 smoothie. So this maximum possible moles is what you should get if you was like a super scion perfect chemist and you did the practical perfectly with no loss. Step 3, we need to find our actual moles of useful product. And again, often in a question, you'd need to calculate this by doing moles equals mass over mR, or maybe moles equals CV. I've just told you we've ended up with 2 moles. So I can say my moles of actual product made is 2. And then very finally, bang it in your percentage yield equation. Percentage yield equals the actual number of moles divided by the maximum possible times by 100. So in this case, we would have a 40% yield. Let's have a look at a few variations on this. So exactly the same question as before, but now for every 1 apple, we need 2 bananas to make our smoothie. So let's see how that affects things. So first of all, let's find our moles of limiting reagent. Now you might be tempted to say, well, the apple's still the limiting reagent because look, there's less moles of apple. But remember, these molar ratios tell you how quickly they're getting used up. For every 1 apple that's used up, 2 bananas are. And so your bananas are getting used up twice as quickly as your apples. You need to cut up twice as many bananas. And so really what I'm doing in my head is the number of moles of apples over its molar ratio, which is 1, and the number of moles of bananas over their molar ratio, which is 2. And you can see for the bananas I get a lower number. That means my bananas are going to run out first. And so my moles of limiting reagent is my moles of bananas, which is 8. Step 2, just like before, we're going to compare our molar ratio of limiting reagent to useful product to find the maximum possible moles of product we should get. Well, the molar ratio is 2 to 1, so every time I use 2 bananas, I only get 1 smoothie. I.e., the moles of smoothie I should get is half the moles of bananas I used. So my maximum possible moles of product is half of 8, which is 4. Step 3, we're going to find our actual number of moles, so our moles of actual, and again I've just told you that is 2. And then step 4, bang it in your percentage yield equation, so that would be 2 over 4 times by 100, 50%. So again, you've got to remember to check this step 2. Look at the molar ratio of your limiting reagent to product. Let's try one more then. So in this one, we're going to have our apples, we're going to have our bananas, our terrible looking bananas, and they're going to make some smoothies, but now the ratio, let's say it's 1 to 1 to 2. And we'll still stick with 5 moles, 8 moles and 2 moles. So these are the moles we started with. This is the number of moles of smoothie we ended up with. So again, maybe you could stop the video now, try this one yourself. Once you've finished, press play again, and I'll go through the answer. Welcome back. So how are we going to do this? First of all, we need to find our limiting reagent. Well, it's all a 1 to 1 ratio, so it's just going to be the reagent with the least moles. So my moles of limiting reagent is 5. Step 2, let's compare our molar ratio of limiting reagent to useful product, which is a 1 to 2 ratio, and that'll tell us how many moles of smoothie we should expect to get if we're perfect. We call that the maximum possible. Now, for every 1 apple, I'll make 2 smoothies. So if I have 5 moles of apples, I should end up with 10 moles of smoothies. So my maximum possible moles is 10. Step 3, let's find the actual number of moles. Now again, I've just told you that is 2. And then step 4, bang it in that percentage yield, so 2 over 10 times by 100, 20%.